GM everybody. Hello. Welcome to another Encode Summer Hackathon sponsored by the Solana Foundation workshop. Today we got a very special speaker with us from Phantom Wallet. Anvit is here and he'll be doing a workshop about signing offline transactions with durable nonces. Since Anvit is getting ready, a final reminder that this is the second to last workshop. Today there'll be one more, and then you'll have around 10 days more to submit your project. Remember, guys, the submission deadline is next Sunday, the 23rd of July in your own local time zone. And of course, the submission form is in your hacker pack that I've already sent you via email and that I've been posting on Discord many times before. So yeah, without further ado, welcome Arvid, and feel free to start your workshop whenever you're ready.
Awesome. Thank you, Navin, for the introduction. So yeah, hi guys. My name is Anvit Mongol. I'm a developer relations engineer at Phantom. I think so. Most of you might already know, but Phantom is like the biggest wallet in the Solana ecosystem. And yeah, I'm very excited to be here. And today I'll be talking about durable nonces and how they are underutilized and how they can be used in your projects. So I'll just quickly share my screen. Awesome. Nevin, can you see my screen?
Yes, we can. Feel free to proceed.
Awesome, perfect. So yeah, today we'll be just feel free to interrupt me if there are any questions. I'm happy to talk to them. But yeah, today we'll be talking about durable and offline transaction signing using nonces. So in my personal opinion, I think durable nonces are one of the most highly underutilized and underappreciated ways to power your Solana dApps and make their user experience more deterministic and more reliable. So before we dive into what durable nonces are and how they can be used, I want to touch upon some applications so that you can appreciate even more why are we even talking about them. So in short, what durable nonces do is they provide an opportunity for you to create and sign a transaction that can be submitted at any point in the future and much more. So right now, if you sign transactions, you have to submit it within a set period of time. So durable nonces removes this mortality from transactions. And this opens up if you could already imagine, this opens up a wide range of applications that we might not even fathom if we just use normal Solana transactions. So scheduled transaction is one of the most apparent applications because users can pre-sign a transaction and then submit the transaction at a later point. So you can schedule your transactions using durable nonces. Then multi-sig wallets also are a key application of durable nonces, where you have a multi-sig where different people have to sign, or different people having different systems or different wallets have to sign a single transaction, and this is very difficult to do without programmable wallets or durable nonces. And then you have programs require future interaction, and these include decentralized derivatives platforms as well. For example, there might be complex transactions that might need to be executed based on some condition. That if let's say Solana is hitting $25, right? We want to buy market buy 1,000 Solana, right? So these kinds of conditions you can sign right now, and then whenever this condition gets gets satisfied, you execute that transaction at some point in the future. So these kind of use cases are really powerful, and durable nonces enable them. And we'll be talking about a lot in this guide. So I'll just jump right into it. So before understanding what durable nonces are, we need to understand what the problem of double spend is. And this problem of double spend is not just limited to blockchains. This is in fact one of the issues which blockchains like Solana solve. So imagine you're buying an NFT on let's say a Magic Eden or a Tensor or any marketplace, and then you sign a transaction that allows that marketplace to extract some SOL from your wallet. So have you ever imagined like what's stopping that marketplace to get that signed transaction and then submitting that transaction on chain again and again until you have no Solana left in your wallet? So what's stopping them? Right. So this is known as the problem of double spend, and one of the core issues which Solana solves. Um, so like a very naive solution could be like you could go through all the history of all the transactions ever submitted on chain, right? And then you could see, okay, if the signature of that transaction, you can find that in the ledger or not. So if you can find it, that means that you're double spending. And if you cannot, then that means, okay, your transaction is unique and you're good to go. But this is not practically possible because like the Solana ledger has a size of greater than 80 terabytes. So doing this for every transaction is not possible at all. Um, so the solution is that you cross-check signatures in a given period of time, in a given period of past time, and discard the transaction if it gets too old. So recent block hashes are used to achieve this. So a block hash is basically a 32 byte, SHA-256 hash, and it is used to indicate, when a client observed the ledger last. And using recent block hashes, transactions are checked in the last 150 blocks. So if the block hash is older than 150 blocks, we reject the transaction. We also reject the transaction if that signature is found within the last 150 blocks. So the only condition we say, okay, this transaction is valid, is when it is within the last 150 blocks, and also we cannot find it in the last 150 blocks, which is around 80 to 90 seconds at the time of this at the time I wrote this guide. It keeps on varying. So as you can, but now that we say this, as you can imagine, this has a major side effect, and that side effect is that we're forcing a mortality on transactions. So that is like for usual cases, for like sends and all, it's fine, right? We don't care about very old, keeping our transactions forever, right? Before, like, between signing and sending them. But like there are use cases, as we already talked about when we started this guide. Like there are conditions, there are use cases which get totally impossible if there's a forced mortality to transactions. So like to summarize, what if I don't want to send the transaction right away? What if I want to sign the transaction offline? As I don't want to, let's say if I don't want to keep my keys in a system that is connected to the network, right? That is connected to the internet. So if I don't want to keep my keys in such a system, how do I sign a transaction? Also, what if I want to co-sign the transaction from multiple devices owned by multiple people, like in a case of a multi-sig DAO? And this co-signing takes usually more than 90 seconds, right? So the answer of all these problems, lies with durable nonces. So what are durable nonces? So durable nonces are similar to block hashes. They're 32 byte alphanumerics, and are used in place of recent block hashes, so that every transaction is unique. And also we remove the mortality on the unexecuted transactions. But like, you might be wondering, then how are we making sure that transactions are unique and that we are sure that we are avoiding the problem of double spend? So whenever you use a recent block hash in place of, if whenever you use a durable nonce instead of a recent block hash in a transaction, you also have a nonce advanced instruction. So this nonce advanced instruction gets prepended to the transaction, and when the transaction is submitted, this nonce advanced instruction changes the value of the nonce. It advances the value of the nonce. So that means the next time you'll be using the same nonce, the value will be different. And that's how we make sure that every time we are using nonces, we're using unique nonces. And that's how we avoid the problem of double spend. So there are two accounts that are involved with durable nonces: the nonce account and the nonce authority. So the nonce account is a very normal account. It's owned by the system program, and its only value addition is that it stores the value of the nonce. That's it. It's also rent free, so you have to maintain the minimum value of, needed for the rent exemption, which is at the time of the writing it was 0.0015 Solana, and it always is kind of lower than 0.0015 Solana. And then the second account is nonce authority, which is the account which controls the nonce account. So this nonce authority basically has some form of some powers, like it can generate a new nonce, it can advance or basically change the value of the nonce, or it can even withdraw the soul from the nonce account. And by default, like the account which creates the nonce account is delegated as the nonce authority, but you have the power to also delegate another random account as the nonce authority. So that's always possible. Cool. So we now know some theory, right? But let's also like try to work our way through like how we can play around with durable nonces. So cool. Like, so we'll use the Solana CLI. I guess you might have already in some way interacted with the Solana CLI. Even if you haven't, that's completely fine. So this is like, sorry, just a second. So this is like a tutorial of how to play around with the Solana, command line interface, and you can play around with it in your own time. I'm sorry, I think I haven't shared this link in the chat, so I'll just do that so that you guys can also see. And it's fine if you're not able to like follow me like completely. There's this guide, and you can take a look at that at a later point as well. So cool. Let's try to just use the Solana CLI to work with durable nonces. So I've already created this nonce authority, which is the set wallet address on my terminal. And now I can basically even show you like the balance. It's like around 1 point something. I'm sorry, yeah, 1.44 Solana, and I'm on DevNet right now. So yeah, I've already have some Solana on this nonce authority.json address. So we can even see like the check the address. So this is the address I'm on. Let's actually start now. So we can start with creating a nonce account. So this is as easy as first like creating. Okay, I think we already have. Okay, I'll just remove these so that we don't face any issues later on. Cool. I think we are good. I'll just remove the last one. Okay, cool. Let's start from scratch. So first we create this nonce account, and we can even like copy this for later use. So this is like the nonce account that we'll play around with. And then we will use the create nonce account instruction to add some Solana to this account and initialize the nonce account. So let's try to run this and see what happens. Okay, cool. So because we're on DevNet, let's just go on SoulScan and see what's up. Okay, so there were two instructions here. One was, as I talked about, like you creating the account, and then we're also, and yeah, we have this transfer amount, which was 0.0015 Solana. And then the second instruction is initialize nonce. So now our nonce account has been initialized. And now when we, try to fetch the Solana nonce from this nonce account, we'll be able to actually see the nonce. So here you go. So this is the nonce that we're currently at. We can also like get some verbose information about our nonce account using the Solana nonce account instruction. And here we go. So we have like the balance that we put in this account, which is 0.0015. We have the minimum balance required, which is, as I told you, like this is always a little bit lower than 0.0015 Solana. We have the nonce block hash, which is exactly what we printed here, the value of the nonce. And then you have the authority, which is the address, which is the nonce authority. So just to make sure, yeah, so this is the nonce authority that we're at. Cool. So now we have like a nonce account and we have a nonce authority. We have both the accounts that we need to play around with durable nonces. So we talked about advancing a nonce, which is like changing the value of the nonce. So you can also do that using the new nonce instruction. So if we do that, we'll again like trigger a transaction and we get a signature. So we can even see what happened here. We only have one instruction here, which is the advanced nonce instruction, and it changes the value of the nonce. So let's see if the value of the nonce got changed or not. Okay, so the nonce block hash has changed. So earlier on, it was this AWX, and now it's something else. So we've advanced the value of the nonce. Cool. So, and then you can also withdraw from the nonce account, but we don't want to do that right now because we still want to play around with this account. So we now know the basics of what durable nonces are and how to make Solana, how to make durable nonce accounts, like the nonce authority and the nonce account. So let's try to use this information in a live example. And the example that I'm using right now is a DAO offline co-signing. So in this example, where if we have like a DAO committee which needs to transfer some Solana from a wallet to another wallet, right? So there are two co-signers here. One is the co-sender wallet, and then one is the sender wallet. And we are trying to, and in this example, what we'll do is we'll sign the transaction first using the co-sender, and the co-sender will pay for the transaction, pay the fees for the transaction. Then we'll send that transaction, the signed transaction, to the sender. The sender will again sign the transaction and then send the Solana from their wallet to the receiver. So that's what we're trying to do here. And we've added one more caveat to this, one more level of difficulty or complexity here. We're saying that the co-sender is let's say a paranoid individual, and they don't connect their system with the internet, right? So they will sign the transaction offline. So although for this example, I won't obviously turn off my internet, but you can do that like after this presentation. You can try that. So for this, we'll create like three new wallets. One will be the sender, and I'll keep copying like these wallet addresses so that it's easier for us later on. Then we have the co-sender. And we finally have the receiver, which will be receiving that SOL. Cool. So we have our three wallets that we'll be playing around with. And what I'll also do is I'll transfer some Solana to the sender and the co-sender. So instead of airdropping, I'll just transfer some Solana let's say 0.01 to the sender.json, and we'll make sure that we are allowing unfunded recipient. Okay. So first we need to have the actual address, and then we need to have the value. I think this should work. Okay, perfect. And we'll do the same for the co-sender. All right, cool. So we have like some Solana in both the sender and the co-sender. And okay, cool. So now we can actually start with the example. So first, to actually demonstrate you guys like what the power of durable nonces here is, I'll first show this example. I'll first run through this example using recent block hashes. Although we'll attempt to do that, the expected outcome is failure here. So that's very clear here. That we even if we're trying to do this, the expected outcome is failure, which will eventually help us to appreciate what the power of durable nonces is. So the first step is to build a transfer instruction from the sender to the receiver, and then sign it using the co-sender. So to sign an offline transaction, we need two things. We need to include sign only. What it does is it prevents the clients from sending the transaction. So we are only signing right now using the co-sender. We're not sending the transaction, right? So once we sign it, then we are sending the transaction hash to the sender, and they will be the ones who will be signing and sending that. And then the second thing is block hash, which so this parameter lets us specify a recent block hash so that the client does not fetch the block hash in an offline setting. So we're basically hard coding a block hash here. Because we're offline, we cannot fetch the block hash from the internet. So we can do that ourselves. So we can go on SoulScan, and we can copy from the blocks. We are copying the most recent block hash. So okay, and I'll also copy it here. So we have the recent block hash. Cool. Perfect. So now we'll also be needing the pub key of the sender, and when you're trying this, you can turn off your internet at this point, right? After this presentation. So cool. So let's try to copy this and understand what this command is doing. So first of all, we're doing a transfer to the receiver of point. Let's reduce this quantity to 0.0. Let's say 001. As we talked about, we're only signing. We're not sending. Let's include the recent block hash. Let's change this here. The fee payer is the co-sender. We're sending this from the sender's public address. So we'll include that public address here. And then the key pair is co-sender. So let's try to copy this edited command and trigger this. Okay, we have something. So we have the block hash that we use. We have a pair of pub key signature. The pub key is the co-sender's public address, and the signature is the signed transaction, the signature, right? And then we also have an important thing here. We have the absent signers, and this public address is basically the sender's address. And what this command is basically telling us that you cannot send this right now because we need one more signer before we can actually send this, right? So that's a very good way to know that that you're missing a signature. Cool. So we'll also copy this because this pair, this pub key signature pair, because we'll be needing this at a later point. So let's say okay, pk sig, and let's just paste it here. Perfect. Okay, let's go back. And now the next step is, okay, in a real world scenario, what you can imagine is that this offline person has signed the transaction, right? They get this pub key signature key pair, this pair of pub key and signature. They write it down on a paper or in a way they're basically sending that pair offline to the other person who'll be signing it, to the sender. So let's say they do that, and now let's assume that we're in the sender's system, right? And we're trying to sign and send the transaction. So let's copy this command again, and we're copying the next command here. Now we're basically including an allow unfunded recipient, because this is where we're actually sending the wallet, the Solana, to the recipient. And we know that I think this receiver might not have Solana, so we have to mention that allow unfunded recipient. We also mentioned the recent block hash, so we copy this recent block hash and paste it here. We say, okay, we're sending it from the sender, the key pair is sender, and then we need to mention the signer. And this signer needs to be the public key signature pair, which has already signed this transaction before us, right? And this will paste it here. So let's see what happens here. Let's see if we can actually, if this is successful or not. Okay, as I already said when we started this, this was bound to happen. So the hash is expired, right? And why did this happen? Because first we got this recent block hash from source scan. Then the co-signer signed it. They spent around 90 seconds or something, where I was spending that time to talk through all this. Right, we spent around 90 seconds or 120 seconds, and then the sender signed it. Right, and within that time, the block hash expired. And this is like mimicking a very real world scenario where you will have to wait to receive a signed transaction. So here we can clearly see that recent block hashes completely do not work. And this is where we start with durable nonces. Perfect. So let's start this example again with durable nonces. I'll copy this again and I'll paste it here. And let's try to sign this transaction using a durable nonce. So we're saying sign only, but now we have a new thing here. We have a nonce, and we're mentioning the nonce account here. We're also mentioning a block hash. So here, what the block hash will be our nonce. So let's try to print out our currently what the nonce is in our nonce account. So this is our nonce right now. Let's just paste it here. So here, instead of a recent block hash, we'll basically be using our nonce block hash, right? Our nonce, because we don't want to use a recent block hash anymore. So the fee pair will remain as the co-sender. The from will be the sender here, and the key pair, which is signing the transaction, will be the co-sender. So let's try to sign this transaction. Again, we have this similar setup of a pub key signature pair and an absent signer. So let's try to copy this again. Let's say pk sig. And let's go back to our example. And then now, again, we're on the sender system. Assume that we're on the sender's system now. Let's try to sign and send the transaction using a durable nonce. So again, let's edit this to 0.001. The nonce is the nonce account. We also have the nonce authority, which is the nonce authority.json that I've already created before we started this presentation, right? And I also showed you like the address of that nonce authority. We'll edit the block hash as the nonce, and from is the sender, the key pair is the sender, and then we need to edit the PK, the public key signature pair, right? And we also have to, so I think this thing is missing one thing, which is the allow unfunded recipient, which is necessary here because the receiver might not have any soul. So let's see what happens here. Hopefully this is successful now. Okay, perfect. Okay, that's very nice. So as you can see, I spent that similar amount of time blabbing, like 90 to 120 seconds, right? But still, we were able to sign this transaction and send it as well. So let's see what happened in the signature. Okay, we have two instructions here. So one is the advanced nonce here. So what is this? Again, like we've talked about advanced nonce before. So what is advanced nonce doing here? It's basically changing the value of the nonce each time you're sending your transaction. So now the next time someone uses the same nonce account, the value of the nonce will be different. And again, we're avoiding an issue of a double spend here. And we're making sure that every transaction is unique. And then the next instruction is the soul transfer that we enabled for like 0.001 soul. Okay, perfect. So like this was a very simple run through of what durable nonces are, and we've gone through like the basic CLI commands as well. So it's really fun. Like you can play around with it like after the presentation as well, and just get like a good feel of what durable nonces are. And you can also like do that in an offline setting. So that's also like one very unintuitive thing, but you can actually do that. Okay, cool. So now let's okay, we've gone through like 30 minutes, so we have a bunch of other things that I need to discuss. So now we've already seen like the CLI part. Let's see what happens in the Web3.js part. Like if we want to make a dApp, right? So we will have to use the Solana Web3.js. I won't actually be running through like the code and actually triggering that code, but I will run through this example, through this code piece, and then going through like a real world example, a real world dApp that I've created. So it's very simple here. I'll run through this very quickly. So here we're just creating like a nonce authority. We're creating a key pair, a new key pair. And once we have the nonce authority, now we're creating a nonce account using that nonce authority. So again, we're creating a new key pair, a nonce key pair, and then we initialize a transaction. We set the fee pair as the nonce authorities key pair here. That's very important. The fee pair to create a nonce account is always the authority, the nonce authority. And now we have to also set a recent block hash. So for any transaction that needs to be signed, we have to set a recent block hash. Here I'm using an actual recent block hash instead of a nonce block hash, but you can even do that. So you can use a pre-existing nonce account to create this new account, to create this new nonce account, right? You can always do that. But for simplicity, I'm using a recent block hash here to create this nonce account. And then we generate this transaction. We add these two instructions to the transaction. One is like the create account. As we saw before, for a nonce account, creating a nonce account, there are two instructions. One is create account, and then the second one is nonce initialize. And that's what we're doing here. And then we're signing it using the nonce key pair as well as the authority key pair. And then we finally send it. So that's how you create a nonce account. It's pretty simple. There are just two instructions involved here. And then once we have the authority and the nonce account, let's try to actually sign a transaction during a durable nonce, right? Again, it's pretty simple to do that using Solana Web3.js. You don't really need a lot of knowledge here. You create a simple transfer instruction first. And then you create an advanced instruction, nonce advanced instruction, which takes like an authorized key pair, a nonce authority, and the nonce key pair. And then we basically add both of these instructions to the transaction. And this is the most important part here. This is the key part here. And this is like the differentiator between how we normally sign a transaction and how we sign a transaction using a recent block hash. And that is exactly what we've already done before. Like we're using the nonce account's nonce as the recent block hash. We're no longer using a recent block hash as the recent block hash, right? And then we set the fee pair as the pub key. And then we first sign it with the authority key pair, and then we let the user sign the transaction. And then once both of these signatures are present in this transaction, we finally send this transaction. So pretty easy. I'll wait for a second. And are there any questions? Okay, is there any max limit for these transactions with respect to time? So not at all. And that's like the beauty. Like there's literally no time limit to durable nonces. And you can actually like sign a transaction, write the transaction signature on a paper, and like keep it for as long as you want. Right? And then you can, give that paper to like your next of kin, right? Like your mother or like a family member, right? And that transaction could be like, you're sending all your Solana from wallet A to wallet B to their wallet. So it's like it can create so many new use cases that we cannot fathom with, just with normal transactions. All right, so let's run through an example with poll simulation app. So usually, like when you actually cast a vote, what happens is you have, in a real world scenario, you have like a set period of time when you vote for someone, right? You can vote for XYZ. And then when the voting period ends, that's when the vote counts start. At least that's what happens in my country, in India, right? And that's like a real world scenario of how a polling mechanism works. But like if you create a fully on-chain polling mechanism, which many dApps do, which many use cases have already come up with this polling mechanism, this voting mechanism, it's kind of a fake polling mechanism, because what is happening is you're signing it as soon as the user signs a transaction, the state on chain changes. So anyone can go on chain and check, okay, so candidate A has 10 votes, candidate B has 4 votes. So let's just vote for candidate A because they're anyways going to win. So this creates like a skewed voting mechanism, right? And we can avoid this. So we can avoid this using durable nonces. And they can durable nonces, again, a caveat is that we're adding like a centralized entity here, like a database entity here. But this is just for this use case. Durable nonces can be used for other use cases where you don't have to add these databases. But yes, but durable nonces can fix this. So instead of signing and sending the transaction right away, what you're doing is you're telling the voter, okay, hey, you just signed the transaction. Okay, I'm signing a transaction to vote for candidate A. And then me, as the government, will save that transaction, that unsent transaction, unsubmitted transaction in my database, in my ledger. And then when the voting period has ended, I will have like this list of all these transaction signatures, and I'll send them together, all together, at the end of this voting period, right? And as soon as that happens, the state on chain changes after that period instead of changing, while the voting was going on. So this creates a more real world scenario of how a polling, how a poll works. So let's okay, so I'll also copy this so that you can play around with it. um Sorry, yeah. Can we bundle multiple transactions like this and submit it to chain? Absolutely, you can. So you can use sign all transactions. Sign all transactions. So so currently I was using sign transaction. So there's another Web3, there's another provider method known as sign all transactions. So you can use that to sign multiple transactions at once. And then you can also, once you have once you have these signed transactions, you can send them all together at the end. So that's very much possible. Um, cool. So let's go through that example. So here I'll just remove the logs for a second. First of all, I'll create a new log, a new poll here. And currently, so you can play around with this on DevNet. So this is not on mainnet. So that's like one caveat here. Um, cool. So we've created like a new poll, and we have like this new poll address here. So now what I'll do is, let's say me as a person, I want to vote 5 times, right? I want to cast 5 votes. So what I'll do is I'll create 5 nonces for 5 votes each. So okay, it says 5 nonces are prepared, and let's get started. So what now I'll do is I'll first, of course, vote for Solana. So as you can see, like no changes are being done because we're just, assigning a transaction. We're not sending Solana anywhere, right? And it shows like a network fee. And we can even do that very, very quickly. And just observe what's happening here. Like, as you can imagine, like usually signing a transaction isn't this fast. I'm signing a transaction very, very quickly here, right? Can you guess why that is? Um, all right, I can basically tell you, because we're not submitting a transaction on chain right now. And the second most important part here is that we're not fetching a recent block hash whenever we're signing a transaction. Fetching a recent block hash is a network call, right? We have to fetch the block hash from the network. Then we have to prepare a transaction. Then the user signs the transaction and then submits it. So this is the usual flow of what a sign and send transaction is. So this is pretty quick, right? Because we're only signing a transaction and we are not even fetching something from on-chain or not submitting something on-chain, right? So there's literally no network effect happening here. There's literally no network calls happening here. Cool. So we've made 5 votes. Now, when we're done, let's assume that we're done with the voting period. Let's count the votes now. So as soon as we press this, as you can see here, we're sending these durable transactions in one go, and we have the final state, right? So this is a pretty cool example of letting the user sign a transaction, storing that signature, that signed transaction in your database. It could be a centralized database, it could be a decentralized database, right? And then triggering that transaction at a later point in time so that the on-chain state changes at a later point in time, right? So this is a very cool example, and you can play around with it as well. All right, I think that was it. So, um, yeah, are there any questions?
Yeah, seems like the chat has been very active. I see somebody typing another question.
Yeah, I'll just when we are not sending the transaction to the chain, why are we paying fees? That's a very good question. So because we are not sending the transaction, that does not mean that it won't be sent at some point, right? So that's a very important demarcation here. We are paying the fees, but we are not actually sending the Solana right away. So when the transaction is actually submitted on chain, that is when that 0.0001 or like those 5,000 lamp ports will be debited from your account. So that fees is not for signing, but that fees is for sending the transaction when you will eventually send that transaction. So if you don't end up sending that transaction, that fees won't be deducted from your wallet. Let's say I want to store all these transactions in DB and pay the fees only once. Yeah, exactly. So you don't have to, pay the fees every time. When you're actually sending the transaction, that is when that fees will be deducted from your account. Did that answer the question? Yeah.
Cool. Yeah, guys, feel free to post any questions in the chat if you have them. And until you do, I actually have another question, which is the same question I ask all of our workshop speakers, which I think is a very useful question, which is about your bounties. So Phantom is offering a bounty on building a project with durable nonces. So my question is, what kind of project would you like to see? What kind of use cases do you think are very much relevant at this point in time
Right.
as far as durable nonces are concerned?
Absolutely. That's a very good question. And I can like share my screen again and like just emphasize on this part because and like when I created this guide, this section was at the end and people were not like reading this section. But I think this is the most important section, like durable nonsense applications. So you might already see many multi-sig wallets. You might see like decentralized derivatives platforms, but if you actually like, first of all, most of them are not open source, but like the ones that are open source, um, they don't really use very good mechanisms for enabling these use cases. um, they sometimes do uses like they do use Solana programs, but why do something complicated when you can actually do that in a very easy way, right? Durable nonces enable implementing these five use cases without even actually doing a lot of Solana programming, right? And as I showed you, like in the example, if there's a use case where you have to let the user sign a transaction right now, and then but you don't have to like send it right away. So if you can imagine any use case which has that paradigm, then durable nonsense is for you. And in my personal opinion, like cross-chain interactions is like one of the key factors here. So, and why I say this is because on a chain like EVM, and I think like a lot of you might be coming from that background, like that EVM space. So you already know this difference in EVM and in Solana, that you know transactions take a lot of time to confirm in Ethereum. They take around, I don't know, like in some cases they take around 2 minutes, in some cases they take 5 minutes or whatever, right? When the network is congested. So durable nonces are very good for enabling cross-chain interactions. And how? So let's say when you need to interact with a blockchain like Ethereum, and it requires waiting for confirmations, which might take five minutes or whatever. what you could do is you could sign the transaction with the durable nonce and then execute it once the required confirmations from the EVM side are received. So if you have such a cross-chain interaction world, then it's very difficult to work on the Solana side. Because on the Ethereum side, it may take 5 minutes, but on the Solana side, there's no way to wait for 5 minutes, right? Because the transactions confirm in microseconds or whatever, in seconds, right? So that's like, in my personal opinion, a very cool use case for durable nonces. And yeah, and because Phantom is also like now a cross-chain, a multi-chain wallet, we are also like, enabling, these kinds of use cases more and more often now. So yeah, that's like my answer to that question.
Cool. Thank you. Seems like we have one more questions. I'm planning to use this for gaming. Yeah, gaming backend, and we'll be. Go ahead. Sorry.
No, sorry for interrupting. So I'm planning to use this for gaming back and will be using a backend wallet. Will this be still eligible for bounty, or do we need to use a Phantom wallet? Absolutely, you don't need to use a Phantom wallet. You don't need to use a Phantom wallet. You can use any wallet. So the goal for actually enabling this bounty was not for users to, use Phantom, but to get acquainted with Solana, to get acquainted with something like durable nonces, which not even like good developers in Solana are aware of. Because when I posted this on Twitter, I was amazed. Like, there were so many people who were like, "Oh wow, this is so cool. We haven't heard of this," right? So yeah, this is a very cool thing, and you can use any wallet. So that's like a short answer to that.
Cool. I think we don't have any more questions. So yeah, I think we're gonna slowly wrap it up, guys. Thank you very much, Amit, for the wonderful presentation on durable nonces and for answering all the questions and for posting your resources in the chat. And yeah, thank you to everybody else for joining us today. Like I said, this is the second to last workshop, and today we'll have another workshop by Wormhole at 5:30 UK time, and after that it's time to build. But until then, thank you, and see ya guys tomorrow. Goodbye.
Thank you, Daman. Thank you, guys. Bye bye.